Well, welcome everyone. Thanks for being here today. Welcome to our third session of our spring seasonal series. I am super excited to be joined today by our guest, Rick Lowe. Rick, welcome, sir.
Hey, Carlos. Hey, everyone. Thanks for having me.
Yeah, and I can't help but notice that you've got your nice-looking SQL Trail shirt on, which apparently, right, one lucky winner can win today if they mention on social media that they're here. Okay, so what we've been going through various things on our SQL Server Administration 101, and today we are looking to expand on some of that, and we're actually going to reach back into some of the stuff reference some of the stuff that we talked about last time. And so for today's session, we want to talk about execution plans, the fundamentals of execution plans. And just like all of these pieces, there's going to be introductions. You're more than welcome to ask questions, obviously, but we'll go through some intro pieces and try to start it from that perspective. So we're going to be talking about execution plans. We're going to be talking about TempDB, and then we're going to go in and we're going to talk about indexes. Mm-hmm. Right. So that's kind of the plan for today. Does that sound like a good deal?
Yeah. Everything you need to know in 1 hour.
Yeah, that's right. No, that's right. We could spend
introduction. Yeah,
that's right. Each of these we could spend a whole lot of time on. So part of what we want to do is approach the subject. Try to make it a little bit more approachable, and again, give you the concepts or some tools to at least be able to take the next step, right? Mm-hmm. And so now that you can continue to learn, right? To find out more. Okay, so with that, execution plans, right? So let's first talk about what an execution plan is and why we get one. So every time we run a query, so I'm using this one, and hopefully you can see that. So select star from sales, right? And I have a view, right? Store with contacts. So when I do that, SQL Server has to figure out how it's going to return that information, right? What I'm looking for and where is it? Where does it reside? Now, as we bust this view open, we'll see that there are several tables involved. So what it does is it will send the query to the optimizer. The optimizer is going to take a look at that query, and it's going to come up with a way to resolve or to return back what it is you're asking for. And it does that with an execution plan. Right. So for our purposes, or at least the way I think of it, and Rick, you can give us your thoughts. But the execution plan is the set of instructions that SQL Server is going to use to be able to answer your query.
Yeah, that's exactly it. I think kind of the way I think about these is when you write a query in SQL Server, you're basically saying what you want, and the execution plan is the hows. Which SQL Server does for you. You don't have to think about it, but it's the how of what SQL Server does to get that data. Yeah.
Exactly. So now there are a number of different ways that you could go about this. And again, we're taking the one-on-one approach, and we've been using Management Studio. And so we're going to continue with that approach and look at these individually for now. So with this query, for example, I'm going to select star from this view. And again, right, this can be one of those that do as I say, not as I do, because ultimately we don't want to be using select stars in our stuff. So in Management Studio, if I hover over and I actually click on this button here, which is going to be include the actual execution plan. I guess there's two options here to do that, and I can. Okay, so right here, let me go back in if I can do that. Right. So on this guy, what we can do is we can choose to view what's called the estimated plan. Okay, so I can click on this, and without having to run it, I can get some information back. So you'll notice I get a new tab here, and in that tab, I'm going to start seeing some pieces about the execution plan. And I'm hoping that this is big enough that we can interact with it without having to zoom in. So this, in essence, is the execution plan. And there are a number of ways to do that, to look at this. And everybody kind of has their own take. And so I guess I guess I do it both ways. I am actually first going to start at the left and go right. But I also then want to look at the right and then go back to the left. So I guess I'm going to read and then kind of repeat looking backwards, right, as I look at this plan. Is that do you have a better option for looking at the plan, Rick?
No, not really. The only thing I'm very, very, very lazy. So a lot of times I actually won't even necessarily read the entire plan from one side or the other. If you hover over the nodes, you can see some estimated costs, and it's dangerous to do this. And that's not a one-on-one level topic. That's a little bit more advanced as to why it's a little bit dangerous to do this. But usually you can kind of look at the costs in the different nodes and kind of pick out the expensive path.
So you bring up this topic, right, of expensive pieces, right? So part of what we're trying to figure out is where is SQL Server going to be spending the most time with these queries? And then again, with that information, we can then make a decision as to what we need to do, right? So there are kind of two ways to take a peek at that. One, you'll see there's a cost associated with it. Right? So each of these have a cost. You can see this one's 13%, this one's 14%. And as you go over, they'll have different costs. So as it kind of stands out, it looks like this clustered index seek has a cost of 56%, is kind of a candidate, right, for, hey, I'm spending a lot of time there. However, right, Rick also suggested I might hover over that. That hovering can be somewhat cumbersome, so it's a little different, but it sometimes can be easier just to right click and click on properties, and that way you get something that's not going to move all over on you.
Yeah, and also as you get more experience with this and work into higher levels, there is actually more information on the properties window as well.
Yeah, that's right. Yep. Yeah. So here, right, as we mentioned. Although it looks like a simple select, there are a number of moving pieces that are happening with this query. Okay, and the execution plan can start to tell us some pieces that we may want to take a peek at, right? So I know we looked here at the estimated costs, and let's see, if I take a peek here, right, you'll notice that everything here says estimated. Well, under certain conditions, because you may not always be able to rerun all your queries, but when you can, it's super nice to be able to click this, include the actual execution plan, and then run it. When you do that, right, and now we go to properties, you'll see that we have a few additional pieces, right, in terms of the idea of estimated versus actual. And this is one of the first things I think that makes sense for us to address is sometimes SQL Server anticipates that it will take, right? In this case, it thought it was going to take 790 rebinds. It actually took 0, right? And so which in our case is actually good. If it's well. I shouldn't say that. It's because it's always going to depend, right? It's always going to depend. However, one of the things that we'd like to see is our estimated numbers and our actual numbers. They don't necessarily have to match, but we want them to be pretty close, right? And when you start seeing differences, again, that's another indication that you might have a problem. Now I didn't, let's see, other pieces. So sometimes, and again, I was not able to get a query that's going to have this, but occasionally you might see a warning sign or some other type of symbol here on the select statement. Again, this is another opportunity for the optimizer, or for the execution plan rather, to say, hey, I noticed something that's a little bit funky about this, right? You may want to take a peek. The biggest culprit there is going to be data type matches, right? I am taking a character and I'm comparing it to a varchar. Again, that might not seem like a big deal, but SQL Server doesn't do that super great. And it would rather deal with varchars and varchars, right? It would rather match to the same data types, right? Rather than having to do a lot of switching. And that can be another piece of information that we get there. Let's see. I guess anything else that we're taking a peek at from the execution plan, Rick, before we?
No, I can't think of anything else to really drill into in the execution plan. I think the only thing I'd add, maybe just as a comment, is at the 101 level, the difference between the estimated and actual plan is going to be a little bit confusing. But one way to put it is that there's really two ways a query can be slow. A query can be slow because it's poorly written, or a query can be slow because you're putting a lot more data through it, or a lot less data through it than is planned for, which is why you care about those row estimates. So I guess kind of at the 101 level, the actual plan is better for troubleshooting because it can show you both of those issues as opposed to just the first kind. But for reasons that are out of scope for this talk, it's harder to get the actual plan typically. A lot of times the estimated plan is easier.
Right.
Yeah.
Now, having said that, again, right, you can get the actual plan if you can just run it from Management Studio like this, right, and you're able to rerun it. Sometimes stored procedures, right, that make it's a little more challenging because you're actually changing data and you can't always willy-nilly do that. Now, in our last session, we did talk about the SP who is active, right? So if I kick off this query and then I go back over here, there is so last time we ran it, we just ran it as the SP who is active. I can add a parameter called get plans, right? And the SP who is active will actually bring me back a plan for the query that is running. So this is again, kind of you have to kind of be there watching it. We did talk about capturing the output of this and putting it into a table. Which I don't think we got that email out, which that's a reminder that we need to do that. But so in this case here, I can click on the execution plan and now I can see the query from my select top 1,000, but I didn't have to actually run, I didn't actually have to run it. I could capture it in the wild, if you would, right? So that is a potential option. So we do have one that we're going to take a peek at from the AdventureWorks perspective. Let's see if we can. We'll do the actual plan. Let's do this. And now we're going to take a peek. Here we go. So here we wanted to circle back in terms of a warning, right? I see that little warning on the select statement. And now it's telling me that I have looks like my first name, or the first name column when I'm doing a conversion there, right? It's doing that data type conversion. Mm-hmm. Yeah. And that can be something that I want to take a peek at. See, can I get rid of that, or can I force those data types to be the same?
Yeah, it's one of those things that doesn't seem like it make a difference, but it makes the optimizer's job harder. So it flags it for you, which is a really cool feature. We haven't always had that. It came out in, gosh, it was about SQL 2012. We got those.
You're showing your age there, Rick, right?
I am.
Okay, so that is, again, kind of a very high level introduction to the execution plan. I will say, and again, we don't have it here, but every once in a while, you may come up, there's going to be a green bar here that talks about suggested index possible. And if you right click on it, right, it'll there'll be an option here to say show me index suggestion. Show me the index suggestion, I believe it says. And it'll pop that up and it will give you the query or the code to actually be able to write the index. Now we're actually going to talk about indexes a little bit later. So the only word of warning I will give you now is those indexes aren't free, and you just want to be sure that you really have a troublesome query before you start going through and just adding the indexes. I guess I'll leave it at that. Is that fair for now, Rick?
Mm-hmm. Yeah.
And then we can talk about the other people, the other things. Oh, so missing index. Okay, so is that your question, Ryan? Did I get it? Or yeah, okay. Yeah. So now, if you are so in this case, right now, having said that, right, I guess so if you go back to here and you happen to know that, hey, this is my query that's really causing me problems, right? I click on the execution plan and I get the suggestion, right? Then, hey, by all means, right, go for it. You can always try it, preferably in test, but you can try it and then just be prepared to drop it if you run into trouble. Mm-hmm. Okay. So the next piece that we want to talk about is TempDB, right? I guess so. TempDB is going to be one of our system databases, and Rick, it's a little bit special. It's here in the system database, right? So it's apart from everybody else. So maybe let's talk a little bit about why TempDB is special.
Mm-hmm. Yeah. So I like to think about TempDB. There are people who use different comparisons here. I like to think about TempDB as kind of like a whiteboard in an office. It's frightening. That's yet another comparison that's rapidly becoming dated. But yeah, and so if you think about a whiteboard, it's if you're working on a problem, it's very, very important to have that information in front of you while you're working on it. But the second that you're done and have a solution, you're usually kind of okay erasing it. So that's kind of the way to think about TempDB. It's some people think if it's just temporary data, it's not important, and that's not completely true. It does kind of get blown away and recreated every time the server starts. But when SQL Server is actually doing its work, it's actually a critically important DB. And I don't know if we'll get into the details on here, but it also does mean there's some special treatment that TempDB tends to get, even if you don't think you're using it. So there are things, if you write SQL in certain ways, there are times when it's really, really obvious you're going to use TempDB, but well, sometimes run into a person who believes they aren't really using TempDB, and it's even if you don't think you're using it, SQL Server definitely is.
Right.
And every version of SQL Server uses it more intensely. So.
Yeah, so because of that, right, one of the things that we then generally recommend is that, and again, right, so everybody has different, unique circumstances, and flash storage is becoming more, I'm going to say, standard, where it's just across the the enterprise, and everybody's got it, right? You get a flash, and you get a flash, and it didn't used to be that way. Or if you're in a scenario where, right, you have to pick and choose, you're like, well, I don't have enough flash for everybody. So what am I going to give flash to? Actually, your TempDB is probably going to be one of your candidates, right? Or be my candidate, right? Not knowing anything else about the environment, right? That would be my suggestion.
Almost always, yeah.
Yeah. And so, right, as Rick mentioned, so that sometimes mean that we are going to put it off on its its own drive, right? Because again, it's going to it could be different. Now we'll also notice here you can have this with other databases as well, but you'll also know that, or you may notice that your TempDB has multiple files associated with it, right? So if I go into the properties here, and I'm looking at files, you should probably see multiple pieces or multiple records here from a rows data perspective. Now, right, there's lots of information out on the internet in terms of how many you should have. We talked about this actually in our first session, where we want to, depending on your system, we want to match the number of files with the number of processors that I have up to 8. So if I have 16 processors, right, I only need 8 files, right? In this case, in my case, I only have 2 processors, so I only have the 2 files, right? More 8 files aren't going to help me because because of some of the the computation. Only 2 CPUs are available to do work, right? And then we also talked about space, right? So I have a quick example here somewhere. Oh, I closed it. Oh boy, I'm sorry, everybody. I'm going to have to do some typing. Let's see. Great. Well, let me just make sure I didn't put it over here. Oh, and I did. Look at that. Oof. Oh, nice. That was scary. I thought I was going to have to type something. Okay. So we talked about some TempDB and being resized, right? So let's say, for example, again, so if I'm looking at my system, in this case, I've only got 15 or 16 gigabytes available on this drive for TempDB. So again, I'm just using this is really just again a demo to show that it can grow. Permanent temporary tables are not the only reason you'd use TempDB, but again, for our example, that's what we're gonna do. So I'm just gonna insert. I've made a big table, right, using character fields of 1,000, and so now I can see that if I go into my data, you're gonna have to trust me because it was 8K, right now it's 73. So as Rick mentioned, one of the things that I can do, or as I restart SQL Server, those will shrink. Now, interestingly enough, it doesn't happen on the stoppage. I've stopped the system with a service. My SQL Server is off. It won't be until I actually start it back up that it will go through and be like, oh, okay, let me reallocate that space. So where does it get that number from? Again, back in the properties on my files, right? It's getting it here. This is the initial size. And so there are some some sizing considerations that you may have in your in your environment, right? A lot of times for big production environments, right, we're generally looking at going ahead and making these gigabytes in size. Mm-hmm. That way, it just as it has it, and we don't have to worry about the growth as we go on.
Mm-hmm. Yeah, especially in the transaction log, the growth in the data files. I'm not going to say it doesn't hurt you, but it doesn't hurt as much. When the transaction log is growing, though, that can be really painful.
Right. Right.
Well, actually, a lot of people might notice if they reboot their database servers, it seems like performance is really bad for a while afterwards. There's a lot of factors feeding into that, but this actually can be one of them.
Right. Right. Okay. So I guess we've talked about, right? So it's important. We can, again, I guess we didn't have a good example in our execution plan, but our execution plans can use TempDB. looking, we said that if you had to choose, if all of your I/O in your system is not the same, right, then TempDB, we're going to go ahead and give the nod to TempDB there. And then, the consequences of growing. We would like to go ahead and give it what it needs, so it's not having to grow during the transaction pieces. I guess any other thoughts, Rick, before we move on?
I'm always tempted to get too complicated.
Yeah. No.
But, if you see me giving a talk, I'm usually the one who's going on about something that fundamental that hasn't changed in this millennium, and spending too much time talking about it in too much detail. But yeah, no, I don't think I have anything more.
Yeah. Okay. Well, very good. Okay. So then the last thing we want to talk about is so indexes. And for this, I feel like we need to go back. Well, I guess not back to the future. We need to go back to the past, back to the basics, right, of our table and how table structures are put together, right?
Mm-hmm.
Excuse me. Mm-hmm. So, when we create a table, right, and here I just have a simple example, right? My data lives here, and it's going to have a number of columns. Now, this is not. I didn't include all the detail, really, just for brevity, for brevity's sake. However, generally speaking, there's that word generally. Generally speaking, our tables should have a primary key, right? Meaning that is going to keep track of what is unique about that record. And it could be a number. It could just be an auto-incrementing number, right? It could be, in this case, right, a purchase order number, right? So some other system has kind of created the key, or is going to keep track of uniqueness, and then we're just kind of just inheriting that. Right? There could be any number of reasons. I guess I will say that we don't generally like GUIDs as primary keys, but you can have them in your tables, right? Just not the primary key. And when we do that, so when we create that, and I actually want to go back to my other one here for a second, because I had I wanted to take a peek at this table. Let's see. AdventureWorks. Yeah, there we go. So in this case, oh gosh, this one's got multiple keys, which I won't say it's uncommon. It's less common, right? It's not unusual, but it's you won't see it on every table.
You typically only see it in AdventureWorks.
Yeah, that's right. So we have a primary key, and that primary key is going to create what's called a clustered index, meaning the way that the data is stored on the disk, right? So in this case, our data is stored by the business entity. Let me zoom in here just a little bit. By the business entity ID, the address ID. Can I move this? Let's see. I should have moved it before. Come on, there we go. So the business entity ID, the address ID, and the address type ID, right? So it's using all of that to sort it. Okay, and then let me scroll ahead and scroll down, and you will see that I then have, right? So this, as identified by the key, is the clustered index, right? It's how everything is sorted. Now, if I go back to my example, oops, there we go. So if I go back to my example, what we had, I guess, well, you know what? I should really use the same table. That's going to be, so let me script this out really quick. Yeah. Okay, let me get rid of all of this. Just so we can see this. Now, this is not the biggest table, but for our purposes, right, we have these records. And let's just say that both Rick and I want to query this table. And Rick is really interested in the business entity ID and, well, let's see, I guess I should use the example here. Let me take a peek here what this is. Okay, very good. So he is actually really interested in the address ID. That's what he wants to know about. And I want to know about everything else, right? And we are querying, or we're trying to, update or investigate. We're trying to work with this table on these different pieces, right? So Rick is really interested in address ID, and I guess, and in this example, it would make more sense for me to be interested in the other pieces, right? When we have that interest on the table, right, and your applications are trying to update the table and do different things to it, we can create, contention can be created because there's only one table, excuse me. And the way SQL Server has to do it is that, again, this is a kind of a small table, but if, as the tables get larger, there's only the clustered index. The whole table has to go into memory for me to be able to use it, because SQL Server uses everything from memory. So it all has to be in there, and then Rick and I are going to be fighting over these columns, and SQL Server has to keep track of who's got it, and there can be some contention, right, or blocking potentially. So one of the things that we can do is we can actually create copies of the data to help alleviate that contention. And I guess before I go forward, right, I guess any other thoughts or about that, Rick?
No, I think it's good.
Yeah. So we do that. When we do that, we create non-cluster, what are called non-clustered indexes, right? So again, it's a copy of part of the table. I'm not creating an index of the entire table, just a couple of records. So in this example, right, I have created another index based off address ID. And I guess if I'm going to go back to my example, I should really take a look at IX business. Yeah. Is this the one? Look at that. Contact type ID. Wait a second. The object is IX business entity. Oh, I'm in the wrong table. Contact type ID. Here we go. So you'll forgive me. I managed to get ahead of or I didn't pull up the right table, right? So this is the table that we want to look at, right? And in our example, right, Rick is super interested in the contact type ID, right? So what we can do is we can create this index, which creates a copy of the data, and only stores that column, the columns that I include in my index. Does that make sense? Right? So this is almost like a little, I won't call it a mini table, but it's a copy that only includes this column.
And I actually almost think mini table is a fair characterization. That's yeah, I think the thing sometimes people don't realize about non-clustered indexes is, assuming we're talking about normal stuff, so we're not talking column store, we're not talking memory optimized.
Sure.
Literally the only difference between your non-clustered index and your clustered index is, the non-clustered index has fewer columns, or should have fewer columns, and is sorted differently.
Right.
Under the covers, aside from that, they're almost separate entities.
The same, yeah.
Yeah.
Okay. So what this then allows us to do is it allows this table to be in more transactions, because now there are more copies to go around, right? And in some cases, it can actually reduce. So for example, right, so going back to our select star example, right, I'm going to get going back to this other table. And again, choosing the tables with not a lot of columns. But should I get into a scenario where I have a table with lots of columns, right? That index can reduce the amount of data that I'm then working with, right? So again, going back to the execution plan, how am I going to get this information? If I have to use the clustered index, I have to use the whole table.
Mm-hmm.
I don't have an option. I don't have another recourse. Excuse me. And so, right, this is then one of the reasons for us to create these indexes.
Mm-hmm.
And we'll go back to our original query here. And one of the things you can see is, now again, this is good naming conventions, right? Your system might vary. However, we can see that we are reading from, forget that pop-up to go away. So PK, right? PK, right? Again, that primary key, and you can see that I have clustered index there, right? If I go over, what this will allow us to do, and most of them are, in this case, are using the clustered index. Here, these two are actually using these non-clustered indexes to be able to get the information, right? So again, what it does is it reduces the amount of data that I have to work with. And in theory, it could potentially also allow for multiple people to be selecting or to be able to access the table and reduce the contention there, right, on that table. Now, that the word is generally there, right? Because we do run into situations, because we're now keeping multiple copies of the data. We have multiple copies, and every time you update it, I've got to update each of the copies, right? So I'm putting some additional load on the system. And if you are doing a lot of updating to a specific table, it may not make as much sense to have an index there, right? And again, that's one of the things where now I have the information. Do I have to then decide what to do there, right? If this table is heavily updated, do I have to move some of that data out, right? Query it in another table or do something else with it to make that burden a little bit lighter. So that is so when we think about indexes, right? Why do we have an index, right? We have an index because from a sorting perspective, right? And from a data, almost a availability perspective, I'll use that word. And if we have a table that's heavily utilized, indexes can help that table, can help reduce the contention around that table, right? As more people want to use it. Okay, so here is thank you, right? Can you have too many questions? Too many questions? No, you can't have too many questions. Can we have too many indexes?
Yeah. Absolutely. So I think the bullet point version of this would be indexes are generally helpful for selects and generally harmful for inserts, updates, and deletes. And also, every index requires disk space, so there's other harms involved. But
Right.
yeah, it's usually the big one we worry about is every index we add is a drag on our other operations.
Yep. Yeah. So again, some of that is just finding the right cadence. And this is then deciding. A lot of times we see. I guess even going back to. Let me go back to my other one. Wrong query too. So, for example, right, this view the sales view. So, if I take a peek at that and what this actually is, right, I'm selecting a couple of things from several different tables.
Mm-hmm.
So, one of the things that I'll call it issues, right, that we see is that someone will take a view or something that someone else has written, right? And then they'll start utilizing it, and then they'll join on at table X. So the idea is well, they've already kind of written that piece, right? Let me expand on it, and what we end up with is columns that we don't need. And again, that can then throw everything off. So part of what we then in the investigation can go back and decide is, okay, well, do we really need all these columns? Sometimes the answer is yes, right? Well, when it's no, right, that's an easy option to help reduce some of that. So I think from a again, rule of thumb perspective, I feel comfortable, and again, Rick, you can cringe, I guess, if you. I feel comfortable with 5 indexes on a table. Now, again, so some of these 5 indexes. I guess we're already at 4 here, right? Like this table only has 5 rows, and it's got 4 indexes. Right, like that's kind of pushing the limit there, right? On as an example of what the heck am I actually doing here? But obviously, right, you have tables with 10 or more columns, right? 5 indexes, I think I can be okay with. Once you get more than that, right, then I think you do have to start looking at how many records are in the table, right? How much change is happening to the table, things like that. I need more details to know the best way to move forward.
Yeah, I think another good rule of thumb is so one of the more important aspects of an index is that its data is sorted differently than a primary key. So another pretty good rule of thumb is that you should typically only have one index. You typically should not have multiple indexes that reuse the same leftmost column. Or that might be a little bit too extreme, but you shouldn't have the same combination of columns showing up in lots of your indexes.
Right.
Because it gets into unnecessary duplication. Frequently, if you see that, you can kind of combine the indexes into something that would work without having 2 or 3 copies.
Yeah. So this also kind of goes back to our example of the execution plan. The execution plan can say, oh, hey, you know what? I think if you put this index, it will reduce the speed, reduce the time. It has happened, right? I won't say all the time, maybe regularly. It's not uncommon for SQL Server to actually recommend an index, but then not use it. So there's also that piece of it is from a usage perspective, is SQL Server actually using it, right? Because now I have this extra overhead but I'm really getting no benefit as a result.
Yeah, and kind of as a corollary, if you a lot of times you'll find if you add an index, and if you did a really, really good job designing that new index, you might find one of your previous indexes is no longer used because you have a better one.
Yeah. Sure, that's right.
Yeah, so it is important to check the usage and also recommendations.
Yeah. So we hope that you'll join us for our next session for our SQL Server 101, specifically for the developers, right? So we're going to be talking about data types, some query basics, and then temp tables versus temp variables. Brian Combs will be our guest, and that's what we'd like to go through then. So we hope that you'll join us for that final session of our spring SQL Trail seasonal series. Thanks again, everybody, for tuning in. We appreciate your time. We hope this has been helpful, and we hope we'll see you on the SQL Trail.
Yeah.
SQL Data Partners.